Hello, Shivangi. Hello. Hello, Shivangi.
Hello.
Yeah,
Yeah,
should I start or wait for someone to join?
actually start because in the Shillong region there is some issues. Schools have UT exams. That's why in Pune region students are joining and Shillong it's very less. So that's
Okay,
why you
so
start. We'll share the links with the students.
yeah,
And
fine.
for today you just start and record the class. Okay? And start
Okay.
the recording again. Okay?
Yeah, I have started the recording.
Okay,
Okay.
okay, fine.
Yeah. Ready? Wait. Mhm.
One. Okay, fine. I think this is disturbing for you. Remove the cable, bro. In 50% 1 hour is it will take it, I think.
Text.
Okay. In case of problem, I will come to 30. I sit down. Sit. Okay. Go ahead. Ready? One, two, three. Start.
So, good evening, students. Myself, Keval Parmar, am a professor of mathematics. So, today, let's see what we are going to do. We are going to start with a very interesting topic and very conceptual topic, which is known as inverse trigonometric functions. So, I hope you are familiar with the knowledge of functions because we are going to require here. So, let's start now. First, before going into the chapter, let me show you what we'll be covering in this topic. So first, we'll be starting with inverse trigonometric function. So first, we'll go with introduction. So I hope you know what is meant by introduction. Yeah, what is meant by inverse functions. Next, we are going to see domain and range. Domain and range. We know that in the functions chapter, we have studied what is domain and what is range. After that, we are going to do a very interesting part, which is graphs. If you know the graphs of trigonometric functions, it is very easy to get the graph of inverse function. After that, we are next going to do properties. This is the most important part for JEE mains because there are many questions which directly comes from properties of inverse trigonometric function. And last but not the least, we are going to solve some questions based on the inverse trigonometric functions. So yeah, let's start with introduction. Now, before starting, I would like to know ki how do you define functions or how do you see functions? For me, I see function as a very, very, very simple machine in which we give some output and we give some input and we receive an output. So a function can be defined as very simple. It's a machine where we give input and the machine gives us output. So let's say for trigonometric function, suppose we'll take sine function. Sine function में क्या होता है? What is there in the sine function? We give input as an angle. Suppose 30 degree, 45 degree, 60 degree, we give it angle as an input. And after that, we get output as a value. So let's see next. This is what I was talking about. This is a function or this is a machine which takes input and gives us out. For normal trigonometric functions, it is easy to note that the input is an angle. The input is an angle. As we all know, suppose I input 30 degrees. So if I input 30 degrees, it will go into the function. It will become sine function. And what will be the output? Output will be sine 30 degrees. Anyone knows the value of sine 30 degrees? It is half. So we get a value half. So similarly, we can put input as 45 degrees and it will go into the function. We'll get output as a value which is sine 45 degree, which is 1 by root 2. Now, what happens in inverse functions? As we have all seen, in inverse functions, the input and output from the original functions gets interchanged. So here the input was angle, output was value. But now in inverse function, the input will be, can you guess it? Correct. The input will be value and output will be angle. So let's say in the inverse function, I give input as a value. Suppose I give a value of half. So from the value of half, it will go into the function. It will become sine inverse of half. Now, how to think that? How should we think that? Sine inverse of half. Like which angle will give the value of half for sine? So correct here, as we can easily see, is sine 30 degree gives the value half. So here the output will be 30 degrees, which is an angle. Similarly, can you tell me if I give the value input as 1, what will I get as an output? 1, 1. Which angle of sine gives 1? I think 90 degree is my answer. If I input the value 1, then I will get the angle as 90 degree. So this introduction is basically the general concept of function. What are input, what are output. I just want you to remember this one thing from here. In inverse functions, the input is the value and output is we get as angle. Okay, I hope everyone is clear. So from next slide, we are going to dive into inverse trigonometric function. So I hope this knowledge is clear. Let's now take some basic notations and concept of what are inverse trigonometric function. Most of them I have covered. Let's just say here, inverse trigonometric functions are the inverse of basic trigonometric function. What that means? If the basic trigonometric function of sine theta equals to x is the basic trigonometric function, as you all know, can be changed to sine inverse of x equal to theta. Note that it seems that input is x, output is theta. For normal trigonometric functions, the input is angle and output is value. So as we have seen this, very important, it is highlighted here as you can see. The input is the value for inverse trigonometric functions, which is x, and the output is the angle. Now after this, I want you to note a very silly mistakes that are done. But before that, let's get to some examples. We have done these examples. Both of these examples are done. So sine inverse of half. So we have to think what angle of sine will give me the value half. And I hope everyone got the answer 30 degrees. And what value will give one? 90 degrees. I hope you are familiar with the concept of radian. So 30 degrees can also be written as pi by 6 radian. And 90 degree can be written as pi by 2 radian. Now, many a times when I first started inverse trigonometric functions, I used to get very confused with the notation. I used to think कि sine raised to minus 1 x is basically is an exponent. So I can write 1 upon sine x. But that is not the case. So I hope you will also not make the same mistake. It is clearly written here. Sine inverse x is not the same as 1 upon sine x. You cannot just take the reciprocal. Actually, minus 1 is not an exponent. It is just a function. Like you have studied in function, we write the inverse function as f inverse of x. So this is basically not an exponent. We can write 1 upon x. This silly mistake many of times I did. So I would like to clear this misconception. So I hope inverse trigonometric functions is clear. So today, again, I would like to complete until the graphs of inverse trigonometric function. That is, we have gone through introduction. We have seen what are inverse trigonometric functions. We have done all the basic introduction. Now we will study the domain and range. And after that, we will go with the graph. I suppose we could at least finish with the graphs till graphs today. and from next lecture we'll go with properties and questions. So yeah, before going into graphs, let's talk about inverse function. As you have all studied, what are functions, what are one functions, what are onto functions, what are into functions. So that is a basic definition of functions. Key for inverse of a function to exist. What are the necessary conditions? The original function should be 1 and the original function should be onto. I hope you remember what is 1 and onto. And if not, please don't worry, we are going to revise that. So let's see what are 1 and onto functions. Existence of inverse function. As we talked about this, inverse function exists if and only if the original function is 1 and onto. If the function is 1 and onto. So let's see what is 1 function. I hope you remember 1 is the simplest function, which is if this is a mapping of function f from x to y. There are three elements in x, k, l, and m. And there are four elements in y, 1, 2, 3, and 4. So what is a 1 function? 1 function means every element in x should have only one image in y. I hope you know these are called images and these are called pre-images. So every element should have one, only one image. Here we can see K has an image of 1, L has an image of 3, and M has an image of 4. So we can see that every element in X has only one image. Such functions are called 1 functions. And what are onto functions? Let's see that also. Onto functions. Onto functions means every element of B, the other set, should have one pre-image. Do you understand what one pre-image means? Like every element of B should be used. That is basically a onto function. Should be used means they all should have one pre-image. So let's talk about this example. There are four elements in B, 1, 2, 3, and 4. Every one of them has an image, pre-image. 1 has pre-image of A, 2 has pre-image of B, 3 has pre-image of C, 4 has pre-image of D. So let's take this example. As we can see, this is not an onto function. Why? Because here element 3 does not have some pre-image, and it is not a onto function. Acha, can you tell me this function, is this function a 1 function? I guess you are all will be correct because yes, every element in A has one image. Has one image. One image means only one image. That is basically 1 function. So as you can see, these were the examples also. 1, 2, 3. They all have an image. Now, interesting part. Let me see. Is this function a 1 function? 1 function definition says every element in A should have only only one image. So here, as we can see, C and D has the same image, which is 3. So I hope you know what this type of functions are called. Many one function. This type of functions are called many one function. But it is an onto function. Let's talk about onto. It is an onto function because every element of B has one pre-image. And what about this? Again, we can see 4 here has no pre-image. So this is not a onto function. So I hope it is clear or you have revised for what is a 1 function and what is a onto function. So for inverse function to exist, the original function should be 1 and onto. Now, why I did this? Because I want to know in the next slide, we are going to talk about trigonometric function. Are trigonometric functions 1 function? Are trigonometric functions onto function? Because if they are not 1 and onto, then we cannot define their inverse. So let's see the problem with trigonometric function. Let's take for example sine function. This is a sine function. This is a map diagram. So as we can see, if I give input 30 degrees, so sine 30 degrees also half. I hope you are familiar with higher angles. Sine 150 degrees also half. Sine 390 degree is also half. So what is the problem here? You see 30, 150, 390. They all have the same image. So this makes the function many one. This is a many one function. We have seen such example. Since this is a many one function, its inverse cannot exist. So what we have to do for many one functions? We have to make this function 1 1 such that there will be only one answer for unique input. For example, 30 degree will give half, 45 degree will give 1 by root 2. So basically we have to, I think, eliminate 150 degree and 390 degree. Now I hope you are familiar with the domain and codomain, like domain and range of trigonometric functions. So till now, I guess we have covered three things. What is a function? Very important. Input and output of inverse trigonometric function. Second, we saw what are inverse trigonometric functions, how are they defined. Third, and the most important part, how do we define inverse trigonometric functions? Because this is not a many one function. This is not a one function. So to make a function 1 1, I will give you an idea how to make a function 1 1. The process is called, we can see y is equal to sin x is not a 1 1 function, hence we cannot define its inverse. The process is called curtailing the domain. Now, curtailing means we have to, the domain of sine is very big, like whole real numbers, sine ka domain. We have to curtail it to small, only small part. We have to reduce the domain. So how we can reduce that? See, domain and range out here. First, let us see domain and range. This is what we talked about, curtailing the domain. First, let me see the domain and range of y equals to sin x. Y equal to sin x, we have the domain like whole real number line. It goes on and on and on. So what we did, from this much domain, we restricted the domain of sin x from minus pi by 2 to pi by 2. You can see the red graph. So we restricted the domain. That means we restricted the graph from minus pi by 2 to pi by 2. Now, if we look at only this part, we can see that from minus 1 to 1, each angle from minus pi by 2 to pi by 2, the function is taking a unique value. What value is the function taking? Unique value. So we can see at 0, it is 0. At pi by 2, it is 1. At minus pi by 2, it is minus 1. So basically, we have seen that by reducing the domain, the function can be turned into 1 function. So if we reduce a domain, we can see that the function is 1 1. That is, for one input, we will get only one output. Now, don't take me wrong. In inverse function, now the input will be from minus pi by 2 to pi by 2. So minus pi by 2 means from minus 90 degrees to plus 90 degrees. We cannot input the values. Yeah, we cannot input the values in the sine after 90 degrees, such as 150 degrees. Why? Because if we input that value, the function will become many one. So for the function to be 1 now we restricted the domain of sin x from minus pi by 2 to pi by 2, and obviously the range remains the same from minus 1 to 1. So from minus pi by 2 pi by 2, minus 1 to 1. This is the domain. This is the range. So as we know, as we have talked earlier, for the inverse function, the domain and range get swapped. Basically, input and output gets swapped. So for inverse sine function, this will be swapped, and this will be the domain, and this will be the range. Domain means input. What is input? Input is the value which is from -1 to 1, and what we will get an output minus pi by 2 to pi by. So by this process, by curtailing the domain, we can reduce the function from many one to one. Now, this is we have done this for sine. Similarly, we have to do for all other trigonometric functions. What are other trigonometric functions? Cos, tan, cot, sec, and cosec. We have done all that. Let's see how we curtail the domain of other functions. So these are the trigonometric functions, range and domain. Sine ka domain is from R, range is -1 to 1, but we have curtailed it from R to minus pi by 2 to pi by 2. And same is for cosine ka domain is also all real. Tan ka domain all real minus this is odd multiples. Odd multiples. Odd multiples of pi by 2. Because the value is not defined at odd multiples of pi by 2. I say 1090, 10217, the values are not defined. So from this, domain for inverse function will be shifted in the range, and range will be shifted to domain. Now, do not worry, there is no change in the range. There is no change in the range. We have just restricted the domain. So the domain of inverse trigonometric function will be the range, as we can see here. This is the very, 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 very important part to remember. So as we can see, if the range has become domain, there is no change here. -1 to 1, -1 to 1, R, R -1 to 1, R and R. Sine, the range of sine has become domain of sine inverse. Look at this part. Range of sine inverse. We have curtailed the domain of sine inverse from minus pi by 2 to pi by 2. We have curtailed the domain of cos inverse from 0 to pi, the range of cos inverse. This is known as PVR, which is principal value range. Please don't forget these terms, principal value range. So what are principal value range? Principal value of range are, if we have to now give the output of sine inverse, yeah, output of inverse trigonometric functions from these values. It will be more clear when we take some examples. Okay, let's try one example. Suppose I ask the value of sine inverse of root 3 by 2. Sine inverse of root 3 by 2. So the output will be an angle. So I have to give an angle which is in this range, -90 to 90. It's very simple. Sine inverse of root 3 by 2. So which angle of sine gives root 3 by 2? Yes, 60 degrees. So 60 degrees, now we have to check, belongs to minus pi by 2 to pi by 2. So 60 degree obviously comes in this range, -90 to +90. So yeah, 60 degree will be my answer. So we have to make sure that whatever answer we give lies in this range. Now I will give you some time, like you can pause the video or we can take 20 seconds to go through the domain. Some interesting properties. Okay, the domain of sine inverse, cosec inverse, and tan inverse is same from minus pi by 2 to pi by 2. Cosec inverse, we cannot get 0 because cosec inverse of 0 is like 1 upon sine 0. The 1 upon 0 is not defined. And the domain of cos inverse, sec inverse, and cot inverse. Cos, sec, and cot is from 0 to pi. Obviously, there are round brackets here because again, for tan, the value at pi by 2 is not defined. Same for cot, the value at pi is not defined. So there are round brackets. Round brackets means that number is not included. Like my pi by 2 is not included here, but included here because this is square bracket. So I hope we will remember this part, which is principal value range. Very, 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 very important. Domain is not that important because we know this also we are studying from trigonometry. So let's recap again. The domain of sine inverse is minus pi by 2 to pi by 2. The domain of cos inverse is 0 to pi. The domain of cosec inverse is minus pi by 2 to pi by 2. Remember, sine, cosec, and tan have the same domain. Cos, sec, and cot have the same domain. So if I remember of sine and cos, I can remember all the other things. So let me come here. Huh. Now I hope you cannot see and you will you can repeat after myself. The range, principal value range of sine inverse. What is principal value range of sine inverse? Minus pi by 2 to pi by 2, meaning minus 90 to plus 90. Now, if I know the range of sine inverse principal value range, which is the PVR, then the same is applied for tan and cosec. So tan and cosec also have PVR from minus pi by 2 to pi by. Now let's again go for PVR of cos inverse. So cos inverse is PVR is from 0 to pi. From 0 to pi. Now if I know cos inverse PVR, then which other trigonometric functions I know? Sec inverse and cot inverse. Sec inverse and cot inverse also have their PVR from 0 to pi. So I hope you remember because we are going to do very interesting and very challenging sums in the next lecture on this, on PVR. I'm stressing very much here this PVR because this is a base of inverse trigonometry. There are many complex problems where this basic fundamental comes and we solve it like this. So after defining domain and range of inverse trigonometric function, do you remember what we were going to do next? I hope you remember because we were going to cover domain range and graphs and graphs. So I will give you one very nice method to get the graph of an inverse function. So if I know the graph of the original function, let's say suppose if I know the graph of sine x, if I know the graph of sine x, then we can easily by 2 steps get the graph of sine inverse x. Now what are those 2 steps? But do you remember the graph of sine x? It's like a wave. I hope you remember. So let's see what are those 2 steps to get the graph of inverse function. Again, this is the steps I'm going to give you are not for inverse trigonometric function. They are for any inverse function. If we know the graph of original function, we can get the graph of inverse function by these 2 steps. So let's see. So before that, to make it even more simpler for you guys to remember the range or the principal value range or the PVR, I have given some thought about this quadrants of inverse trigonometric function. So I hope you have studied this in trigonometric first chapter. If this is a quadrant, this is the first quadrant, second quadrant, third quadrant, fourth quadrant. We all remember the formula A S T C. What is this ASTC? A means all trigonometric ratios are positive. S means sine and cosec are positive. T means tan and cot. C means cos and sec. So if we talk about second quadrant, all the ratios apart from sine and cosec will give a negative answer, a negative value. Same is for third, all the values except for tan and cot will give negative value. Same is for fourth. Now, let us see what are the PVR covered by our inverse trigonometric function. So, do you remember? This is just a small test, not a test. Sine inverse का PVR. I hope you guessed it right at minus pi by 2 to pi by 2. So, we all know that for positive angles we measure anti-clockwise and for negative angles we measure clockwise. So if I want to go to minus pi by 2, I have to measure clockwise, this is 0 degrees. If I go anti-clockwise, this is pi by 2 and this is pi. And if I go clockwise, then this will be minus pi by 2. So the PVR of sine is from minus pi by 2 to pi by 2. From here to here. Sine inverse, sorry. So this means that sine inverse covers which quadrants? First and fourth. First and fourth. Now I am discussing in very detail for sine inverse. Rest you'll tell me the answer. So for sine inverse, first quadrant and fourth quadrant. If sine inverse gets a positive input, then which quadrant will I see for output? First quadrant. Because for positive input, the output will be positive. If sine inverse gives negative input, suppose minus half, minus root 3 by 2, then which quadrant I will see? Fourth quadrant. Because in fourth quadrant, sine is negative. So we have to see first and fourth quadrant for sine inverse. Similarly, first and fourth quadrant are same. If I know sine inverse, which other two trigonometric functions I know? Let me think. Tan inverse and cosec inverse. So sine inverse, tan inverse, and cosec inverse have the PVR in first and fourth quadrant. Now, what about cos, sec, and cot? Cos, sec, and cot have from 0 to pi. Which quadrant 0 to pi covers? First quadrant and second quadrant. So this is for cos inverse, sec inverse, and cot inverse. Obviously, pi by 2 will not come for cot inverse as sine becomes negative, but that's all. We just have to do this. It's fine. So just remember, let's talk about cos. If I give a positive value input, suppose cos inverse of half, then which quadrant I have to look? For positive angles, I have to look. And since cos inverse only has first and second quadrant in which I can give my answer, in which quadrant cos is positive? The first quadrant. So for positive input value, I have to look in the first quadrant. If negative input value comes, I have to look into second quadrant. Okay, same is for cot. If positive value, will look into first quadrant. Negative value will look into second quadrant. So this is a quadrant distribution of inverse trigonometric function. I hope this will make it easier for you to remember. For sine, cosec, and tan, first and fourth quadrant. For cos, sec, and cot, first and second quadrant. And remember here, in fourth quadrant, we move clockwise since we want minus pi by 2. Okay, I hope this is clear. Now let's move into the next part, which is graphs of ITF. I hope you remember the graph of sin x. The graph of sin x is this. But for inverse to exist, again, we have compressed, or what was that word? Curtailed the graph of sin x. So curtailing from minus pi by 2 to pi by 2, again you can see the red highlighted portion. This is the graph of sin x for me. So only look through this window. Now, if I want to get the inverse of sin x, what should I do? What should I do? What should I do? I told you, remember how many steps? Two steps. So for two steps, what are those two steps? Again, remember, inverse function के ग्राफ में, for the graph of inverse function, as input and output gets interchanged, which means domain and range gets interchanged, which means x and y gets interchanged. Input was x, output was y. Here it will get interchanged, meaning the x axis and y axis will also get interchanged. Now, what are those two steps? Just keep in mind that thing, the x and y axis will be interchanged. First step, rotate 90-degree anti-clockwise. So if I rotate this graph 90-degree anti-clockwise like this, so from here it will go here. So can you imagine how will it look? I'll give you 5 seconds to imagine it. How will it look if I rotate 90-degree anti-clockwise like this shape? It will look like this. If I rotate this 90-degree anti-clockwise, it will look like this. This is step one. Now for step two. Step two, what is step two? After step two, we'll get the graph of inverse sine. Take mirror image in Y. So if I place a mirror here, and I take the mirror image, so basically this will come this. So how will it look? I hope you can imagine it. This function will just mirror image like this. So you have imagined it, it will look like this. If I take the mirror image in Y, like this, it will be like this. I hope you can imagine. Now, if you don't like to imagine mirror image, you can just turn the page. It's very simple. I used to do that only. That is very good trick. Uh, Suppose this is a book. I made the graph of sine here. I rotated it anti-clockwise direction. Now I just need to turn the page and see the reflection. Like if I turn this page here and back of the page, the graph I'll get that will be of this sine inverse from here to here. So this is the graph of sine inverse. As I told you, we have to keep remember one thing. The input output gets interchanged means x and y axis get interchanged. Meaning here x axis was angle input, y axis was value output. Now it gets interchanged. Means on x axis we will get value. See, -1, -0.51, and on y axis we'll get output. या फिर angle. Input means domain. Now, if you remember the domain of sine inverse, it is from -1 to 1. So the graph will not go beyond -1 and beyond 1. It will be between -1 and 1. And if you remember the PVR, let's see, what was the PVR for sine inverse? First and fourth quadrant, meaning -5/2 to 5/2. So the graph on y-axis, which is the output, which is the range, which is the PVR, is between -5/2 to 5/2, as you can see. This is the graph of sine inverse. If we know the graph of sine, we have to just apply two steps. We'll get the graph of sine inverse. Let's try one more time with cos inverse. I hope you are ready. And now I want you to take your imagination, or if you have a book and pen, you can draw simultaneously. So if I take the graph of cos inverse, do you know the graph of cos inverse? I hope yes. The graph is same as sine, it is a shifted something like. Now, to get again, we have to curtail the domain. Do you remember the domain of cos inverse? Yeah, domain of cos. It was real number. We curtailed it in first and second quadrant, which is 0 to pi. You can see the highlighted one. Now we'll only see between 0 to pi. Take this graph. What was step one? Rotate 90-degree anti-clockwise. Sorry, this is clockwise for you. This is anti-clockwise for you. rotate 90-degree anti-clockwise. I hope you get it. Like, sorry for the confusion. If I rotate this 90-degree anti-clockwise, I will get something like this. 1 second, give me 1 second. Yeah. So if I rotate this 90-degree anti-clockwise, have you done it in your book or have you imagined it? If I rotate 90-degree anti-clockwise, how will it look? I hope you have done it. It look like there is some issue. Next slide is not coming. Wait, let me solve it. So yeah, this was a graph of cos. We had reduced it from 0 to pi. There was some network issue. Sorry about that. And we have now rotated it 90-degree anti-clockwise. It look like this. I hope you can see 90-degree anti-clockwise. Now, what is the second step? The second step is to take the mirror image in Y. If I take mirror image, it will look like this. So I hope you are getting, if I take it will look like this, the mirror image. And again, the input output gets interchanged, X and Y axis get interchanged. Here, X axis. What was on X axis? There were angles. What was on Y axis? There were values. Now there will be values on Y axis and angles on X. See here, X axis has values 0, 0.51, and Y axis is angle. Again, we can easily see that cos lies between -1 to 1. So the graph will not go beyond -1 and beyond 1. And what was the what domain we curtailed from? 0 to pi. So the graph now will only be between 0 to pi. This is the graph of cos inverse. Similarly, we can do for tan inverse, sec inverse, cot inverse, and cosec inverse. Let's just see that. I hope you are ready. If I take tan inverse, this is the tan inverse graph. Again, we have to curtail the domain. If I remember tan inverse, what was the graph of tan inverse? Yeah, what was the curtailed domain of tan inverse? From minus pi by 2 to pi by 2. This was the part. What are the two steps? Rotate 90-degree anti-clockwise. If I rotate it 90-degree anti-clockwise, how will I get? I'll get something like this. If I rotate like this. And the next step is to take its mirror image. So if I take mirror image in y-axis, this is suppose my mirror. If I take mirror image, it will be like this. So this is the mirror. So this will be the graph of tan inverse. Now again, x-axis has angles. Here x-axis will have values. Y-axis has values. Y-axis will have angles. So what was the part we curtailed the domain to? Achal, let me. This is the graph. See, the same graph is there. Just rub here. So y-axis values. The domain was curtailed from minus pi by 2 to pi by 2. That means here the graph will be between minus pi by 2 and pi by 2. You can see here. And along this will be all real numbers. Huh? It is going from all real numbers. So it will be from minus pi by 2 to pi by 2. Same now we'll see about cot inverse. I hope you are understanding how we are proceeding. So sine cos tan are simple. Same we can do for cosec sec and cot. Cosec sec and cot, I hope you remember the graphs. If you remember the graph, then it is very, very simple to get inverse graph. We have to only do two steps. Now let's see cot inverse. Sorry, this cot inverse. This is the graph of cot inverse. What first step we have to do? Curtail the domain. What is the domain of cot inverse? We curtailed again cos inverse, cot inverse, and sec inverse are same. Cos inverse 0 to pi, that means cot inverse will also be from 0 to pi. This is a domain we curtailed. So take this graph, rotate 90-degree anti-clockwise. It will look like this. Then take mirror image. This. It will look like this. And what was other one key point we have to remember? The angle was on x. Now it will be on y. Again, it was from 0 to, this is pi. So here again, it is between 0 to pi. And here it was like from infinity to infinity, infinite to infinity. Lastly, we can see the both the graphs of which are remaining. Sec. Sec. Do you remember sec? Cos inverse, sec inverse, cot inverse. Domain is from 0 to pi. So take this part, rotate 90-degree anti-clockwise, and take mirror image. You'll get this. If I rotate 90-degree anti-clockwise, what will I get? Something like this. No, I did it wrong. Okay, I hope you got it. 90-degree anti-clockwise. And then take the mirror image. And lastly, the graph of cosec inverse. Cosec inverse is same as sine inverse. From minus pi by 2 to pi by 2. Take this graph, rotate 90-degree anti-clockwise, and take the mirror image. It will be between minus pi by 2 and pi by 2, as we have curtailed the domain here. So let's again go through what we did today. We look at two most important parts for today, which were, okay, let's recap from start. We started with what are inverse trigonometric function. We started what is a function. We basically got a definition of what is a function. Input output machine, Then we got what are inverse functions, how do we define inverse trigonometric functions. Then third is the most important part, curtailing the domain. Curtailing the domain means we have to restrict the domain of all the trigonometric functions. So for sine, tan, and cosec, minus pi by 2 to pi by 2. For cos, sec, and cot, 0 to pi. This is the most important part. The principal value range, we will be going to do sums questions based on that next time. And the last but not the least, the graphs. We look how to get graph of inverse function if we know the graphs of original function. Rotate 90-degree anti-clockwise. Sorry, again I missed. Rotate 90-degree anti-clockwise and then take mirror image in Y. You'll get the graph of inverse. But before, remember to restrict the domain. So graphs, I'll seriously tell you, graphs, we learn graphs because it just makes our speed better. Like if there will be questions where it will be very easy to solve with graph, we can directly see, we directly refer the graph. If we know the graphs of the inverse function, we'll directly get the values and all, we'll see its use. So graph is important. I hope you remember the graph of sine, cos, tan, cosec, sec, cot. So we can easily get the graph of sine inverse, cos inverse, tan inverse, and so on. So this was the last part. I hope next time we are going to do questions and we'll be starting with properties of inverse trigonometric functions, which is the most important part. So after doing that, we'll get back to you in next lecture. I hope it is tomorrow only. See you. Bye bye. Chalo.